Morning, everyone. Good afternoon, good evening, wherever you happen to be. So I'd like to welcome everyone to this learning session. Apologies for my video off, but I'm having bandwidth problems. It's great to see participation from not only project partners and colleagues, but other partner donors, hopefully, and other leaders. We'll have just a few minutes of introduction. Chiedozie Agesi will be our presenter for the day, and we'll talk for around 35-40 minutes, and then we'll end with 15 minutes Q&A session. So just as background, the NextGen Cassava breeding project is reaching the latter part of its second phase, nearly 10 years after beginning with a short-term scoping study. It's co-funded with the Foreign Commonwealth and Development Office, FCDO, which has been a stable co-funding and thought partner through both phases. Kathy Kahn was the initiating program officer and developed the concept through a couple convenings and later proposal development with Christina Owen, a colleague who recently left the foundation. I came into this story after joining the foundation about 9 years ago. Although this is our main cassava breeding investment to the CGIAR, the lead institute is Cornell University, another story, with IITA as the largest sub-awardee and funding also to CIAT. The original national partners were the National Root Crop Research Institute at Umudike, Nigeria, and the National Crops Research
Jim, you've dropped off of audio. If Jim can't get back on audio, Chiedozie, maybe we just go ahead and dive in.
Okay, just a moment.
Chiedozie, do you want to maybe introduce the team, because I think that was where Jim was heading, just who's on the call.
Right. So we have, I think he was saying that we have Cornell coordinating National Root Crop Research Institute in Nigeria, one of the national programs, and the National Crops Resources Research Institute of Uganda, Namulonge, Uganda, the national program for Uganda. Jim, if you're back in, just let me know, I'll stop. And
okay,
then
yeah.
Okay, please go ahead.
Thanks. Yeah, so this was initially a research project to test and validate genomic selection in cassava, and then was adapted to cover the entire breeding process later in the second phase, while continuing a significant research component for bottleneck issues that hinder breeding. Telling the story today for NextGen will be the project leader, Chiedozie Agesi, who's also a senior scientist at IITA. He's been leading the NextGen project for nearly 6 years and is based at NRCRI in Umudike. He also has an adjunct professor status in 2 departments at Cornell University. He's served as a yam breeder and a cassava breeder at NRCRI, cassava breeder at CIAT, an assistant director, research coordinator for breeding and biotech at NRCRI, and is Nigeria's most recent recipient of the Achiever in Agriculture Award. A dynamic manager, he has a vision to help grow his country through improving its most important crop, fortunately stretching that vision to include many other countries in sub-Saharan Africa. Sorry for the techno glitch. Chiedozie, I'll turn it over to you.
Thank you, Jim, and thank you, everyone. I'm glad to be here to talk to us about NextGen Cassava and the progress we've made and how important we think that progress is for the future of Africa's agricultural productivity. At some point, I may turn off the video to have enough bandwidth to run, but let's go. Today's talk, I'll talk about NextGen's evolution, the project and the evolution, and the major achievements and what we think should be next. And this is the vision of NextGen, to empower farmers through innovative, sustainable cassava breeding. We are in 4 continents, 13 organizations. 13 organizations as the main grantees, but we also have about 7, should I even say 8 now, additional countries, and I'll talk about that in a moment. But it's important to say that we wouldn't have achieved the success we had without the excellent coordination from Cornell University, the support system that Cornell University presents, especially the principal investigator who is here, Ronnie Kaufman. Ronnie Kaufman is an experienced plant breeder, and I bet most of us know him. But this is not the entire team, but these are the principal members of the project from all over the place, ITA, ITA Nigeria, NRCRI, Uganda, from all the 13 organizations are here. But the key people that have helped me to lead this project are also here in this call, the leaders of the project, especially the steering team. And I'll talk about that later too. So Cassava. Why cassava? Cassava is the ultimate climate change resilient crop, not just for Africa, but because NextGen is Africa focused, it will look like my talk will be mostly focusing on Africa. But we are in 4 continents as a funded project, but we're actually in 5 continents as an impact project, because we're already working in Southeast Asia with partners with results or products from our project. But cassava is very important for us because it can survive in places where we have elevated carbon dioxide or temperature increases, besides the naturally occurring drought that happens from in different places. It's consumed by hundreds of millions of people. In Africa, most people depend on them as this major staple. Africa produces more than half of the world's cassava and also consumes more than any other continent. That's why it's important. But it's important because it is hardy, can be stored in the ground as a fallback food security crop. One thing that excites us for working in cassava is that it is a crop that is grown and processed by women for home consumption, and it has a potential. Can I have your attention? It has a potential to help women make income, make for more income. I'm sorry, I'm trying to get used to the teams, but despite all this importance, we've witnessed a slow rate of genetic gain in the farmers' fields, and that is the yield has not really increased in the farmers' field as we would desire, and it's taking us a long time to move the yield from just 6 tons to even 10 tons. In the last 5 decades, and we've been working on making that happen. So what do we need to do to address these challenges? We know that as breeders, from the breeders' equation, there are things we need to manipulate or manage to improve the situation. And when you look at prediction accuracy, selection intensity, or genetic diversity, and the time it takes to turn over a new population, a new variety, then you look at the things that will drive those changes with you. So NextGen phase 1 had to focus on those things like Jim mentioned. We were testing and looking at looking at proof of concept for certain things, especially for genomic selection to make it work. But we know that we needed to fix the long breeding cycle. Poor flowering in cassava, I'll talk about that in a moment, and the difficulties for making hybridization. Poor knowledge of the genetic basis of some traits and lack of genomic resources. And I'm going to talk about the whole thing in the yellow as our phase one emphasis or focus, and the ones in the green are the ones we had to include, having identified them to provide a solution to these challenges. So in phase one, we worked on developing genomic resources, reducing the breeding cycle, enhancing flowering, and providing a database for the crop community, and also provide some insights into some of the genetic traits that we think are important. So talking about developing genomic resources, which will be the foundation for genomics assisted breeding, we had to, this chart here shows you from the left side in the mid-90s, my senior colleague or my former mentor, Martin Fregene, and the work they did, there were just a couple of hundred of markers that were developed until the time of NextGen. And we got up to 22,000, and we were very excited when we had that. But in recent times, we've moved up to HAP maps that are 20 million SNPs right now from over 1,000 clones. And so far, since the project started, we have SNP data from almost over 40,000 cassava accessions. And that is one rich resource that NextGen has been able to provide. Talking about cycle time, typically cassava on a conservative time scale will take between 5 to 7 years, but it could be up to between 8 to 10 years to have a breeding cycle, because we have few seeds per cross, low multiplication ratio of the planting material, and resource intensive phenotyping. The roots are bulky and perishable, and it's not as easy to manage like the grain crops. The arrows in the red will show you the typical phenotype-based selection system. In fact, this whole chart is a typical. The next one will show you the efforts we've made with the genomic resources available to us. Again, the same chart or the same cartoon. The red arrow is a conventional way we breed based on phenotype alone, and the ones in the blue arrow is using genomic resources. We've been able to shorten the time to breeding by more than half, and we've reduced it to at least 2 years now. I will save us the pain of how we ambitiously, as a project, we sought to make that a 1-year cycle. And we could do that, but we saw that we were not making the kind of gains or progress. Even, you can be going fast to nowhere. But we wanted to go fast to somewhere. So we had to advise ourselves that 2 years is the right way to go. So when you have genomic selection breeding system, you have cycle 0. You start from cycle 0, which is a founding population, and you go to cycle 1, cycle 2, cycle 3. And because of the time to start for each of our partners in the different countries, you can see the stage where people are, or the teams are right now. And the good thing is that some are ahead of others, and they are able to advise others so that we all don't go to make the same mistakes or take the wrong steps at particular time for each of the things. So the cartoon you see on the right is what people have done each for a full cycle. You make crosses, you phenotype, you select. From the selection, you make crosses again. And that has been happening. Remember I mentioned that flowering is important. It's not just for it to flower. You need the plants to flower. Some don't even flower at all. Some varieties don't flower at all. So how do we get to tap the genes good alleles or the good genes in those genotypes of varieties. So we had to introduce some techniques that are known but have been tested in the past. We had to work around it to use photoperiod manipulation, plant growth regulators, and pruning. And at sometimes we had to combine these methods to techniques to help us increase. The important thing is that we've seen the things that work and the ones that don't work, and we have seen that plant growth regulators and pruning are very repeatable in different places, and we've seen multiple folds of increase in fruit set and in seed set in different continents, whether in South America or in Africa. The next thing we lacked was digital resources, and we had to create a Cassava, a database called Cassava Base. It's a digital ecosystem for breeding data management. One exciting thing for us was the agreement for every team member to accept to have to deposit their data in a fully open access repository. That did not used to happen before NextGen, not just for cassava, for most other crops. And on the basis of this this effort, other databases like yam base, sweet potato base, Musa base, which is for banana, were all developed, and they have all adapted this database to suit their own. But the good thing is that in this environment, you can create your data, you can create your trials, you can, evaluate your trials from this same system, and make analysis also. So, and you can also make selections even within the ecosystem. So what we've been able to achieve is that we have over 1,200 users from 22 programs worldwide. And we have people depositing data from Thailand, though they are not members of the project, but all the African breeding programs and the ones in South America. We have like 18 million phenotypes. This is important for us. And you will see the growth from the last couple of years. We've grown from 9.7, this is not even up to date, is 18 million right now. 9.7 million phenotypes, 2,400 trials to about 4,800 trials right now. And so for me, it's impressive because this is the first time for cassava or for any crop that is not a commercial crop. Now, let me move on to the understanding of the genetics for different traits, whether resilience traits like the virus diseases or insect pests, or nutritional traits or root quality traits. We have many, a lot more than I've put here, and because it's formed a good students project for us, and we've been able to use this, the genomic resources that are available right now to be able to understand some of these traits and how they can be used, manipulated to increase resistance in breeding. And I have two examples that are important for biofortification. So cassava has a toxic component, cyanogenic potential, and we also breeding for provitamin A. So you need to make for these two traits to move in the right direction. So these genetic signals that we have been able to ID now for cassava are very important for us to talk about biofortification as we move forward. Another thing that we've done a lot of work is in breeding for disease resistance. The virus diseases, especially in East and Central Africa, Southern Africa, have been very devastating and cost farmers a lot. So we've been able to, but the brown streak disease is not in in West Africa. So some of the things we did include preemptive breeding for resistance to the virus disease in West Africa, collaborating with our partners in East Africa. We have new high throughput screening methods that we've developed with our partners in Germany, Stefan Winter's lab, DSMZ in Braunschweig. And it's not just for, it's for two things actually. He helps us to do high throughput screening for breeding materials right now. And he also helps us to screen because we want to screen materials before we ship them on an across the continent. So we don't just move materials from South America to Africa because we don't want to complicate things with diseases like frog skin disease that is not in Africa by introducing it to Africa. So we use that lab. It's a reference lab. It's a European reference lab, and they've been very helpful in our work. The other thing we've done, like I mentioned, is that we have developed markers, and I'll show that in a bit, that the people in Southeast Asia, where this mosaic disease is appearing for the first time in the last 2-3 years, they now use our markers to select for resistance to that virus disease. So those are the things we did in phase 1. So moving on to phase 2 quickly, we had to, put in more focus on quality traits, root quality traits, I mean. We had to restructure the program in a way I will describe it from the next slide. We had to emphasize capacity building. It's not just capacity building for the sake of it, but doing it in a sustainable manner. And I'll also talk about that shortly. A breeding program organization, which is one thing that has helped NextGen to thrive and become a model. And this is just the organizational structure that we run. For phase 2, we were no longer dealing with objectives 1, 2, and 3 like projects we run. We are doing this like what we call, John-Luc, my colleague at Cornell, would call it Cassava Breeding Inc. So this became a company that had a survey division, a research division, and a breeding division. So what was the survey division about? It was about, having the product profiles developed, understanding the needs and the preferences of farmers, giving due attention to gender, and doing participatory variety selection. And a couple of slides later, you will see that. We also had a research division whose zone was to give us tools that we could use to sharpen breeding or make for a more efficient breeding. But breeding was still the main focus, and most of our resources were devoted to breeding, and it was devoted to developing new varieties, but also improving new moving us from not just looking at variety development, but also to population improvement. It's also we were very intentional about knowing that each of these things in the graph, excuse me if it is not very pleasant to the eyes, but just look at the center, and that is where NextGen starts from. We start from the center to define, the left and the right side of it. We are customer-centric in our approach. So no matter what the biological components or the market is talking about, we looked at the social characteristics of our clients, which are the farmers, but we had to include the gender component and the and all the other what is their capacity. We had to, even distinguish the typologies. Are they poor farmers, or are they households that are poor? The kind of cassava variety that households that are poor will look at versus the ones that are, well-to-do in different countries. We also had to use citizen science models to identify key traits and winning varieties. I mentioned participatory variety selection. This is happening not just in Nigeria, because you see the map of Nigeria there. We have similar things happening in Uganda and Tanzania. In fact, in Uganda, it has become, we are now using the TRICOT model. TRICOT is short for triadic comparison of technologies, where you have each farmer evaluates 3 varieties. They probably are not the same 3 varieties, but they will be able to tell you the best and the worst performing variety, depending on the traits of importance, including processed food products. and they had to be purposefully selected farmers having social diversity and gender in mind to do that. So in Uganda, like I was saying, it is now part of the pre-release variety trials that are done. Tricot model has been adopted. We are looking forward. Yesterday, I was meeting with the Variety Release Committee of Nigeria, and I made a case for tricot to be considered as an alternative for participatory variety selection for varieties that have to be released. So what have we learned from piloting this work in survey division? It is counterproductive to just say gender and we say, what do women want? So it's not just about women, because it's not easy to say this trait is for women and this trait is for men. We've seen that. But we are looking more at the social differences, like I already described. Methods to survey farmers, producers and consumers are still new to us, so we are testing them and we are fine-tuning them and moving forward with them, knowing that they have worked in the past with other crops and situations, and we are seeing how to adapt it to our own crop and to make it inclusive for breeding. This is important because you can work with the breeder's equation, increase genetic accuracy, prediction accuracy, selection intensity, and even, reduce the time to breeding. But you need to know that what you are breeding is going to be adapted. People are going to accept it and grow it and eat it. That is very important. That's why this division is very important to us as a program. Leaving that to move on to some other things we've done. I mentioned that we have worked with Stefan Winter lab in Germany, and he's helped us to really understand how to move germplasm across the world. Cassava germplasm moves from South America first to Europe. In fact, for cleaning, and it can be returned, or screening, and they can be returned to South America, likewise to Africa. And we've been doing that, and it's been a very good experience for us. Right now, that we think that very soon we'll be able to have the markers to screen in a screen house effectively resistance to some of the virus diseases. We've also paid a lot of attention to root quality traits. The problem with cassava is that it's perishable. Within 24 hours, it begins to deteriorate the roots. So you need to evaluate quickly. So what it means is that we need high throughput systems to do that. And we've been able to translate what the farmer calls, certain traits like swelling ability, working with RTB foods to translate them to measurable traits or indicators that the breeder can use. In fact, we are hoping that in the next within the next year, we'll be able to revise some of our selection indices, including root quality traits. It's already happening on a pilot phase for some of our programs, but I mean to become routine by the time we have validated that. We also have moved our breeding programs to a formal product life cycle and stage gate management system. So every one of our breeding program goes through this now. And this is a typical one that represents what we've done. Last year, Nigeria was able to release 5 varieties, as you can see at the edge here. This is an example for Nigeria. Uganda has also done the same by submitting their dossier for nomination to the Variety Release Committee of Uganda. Now, what did not used to happen was product advancement meetings. So right now, we now have annual product advancement meetings since NextGen started. In the last 2 years, we've been able to host 2. And we don't just do it for IIT-SCG program alone, we do it for even the national programs. And it's a learning process that we have done it 2 times now, and you see the progress or the improvements from the first one. And we hope that by the 3rd one happening next year, we'll be able to even make more progress. This was a new thing that we've been able to introduce. Some of the gains that we've had, you see the chart on the left, the data to the left, which is yellow, is what we've had in the last 50 years before NextGen. Emphasis by, previous breeders was mainly on disease resistance, and and there was some progress made, but you see the jump when we began to use genomics tools and all the other things beyond genomics tools, trying to make for good quality field management and good data management. We've seen a jump in the genetic trend for cassava breeding over the last few years that we started. In the last 8 years, 7-8 years, we've been able to change the trend, and this is for specifically for yield, dry matter, and virus resistance. I mentioned this already, but you can see 5 varieties released in Nigeria and other countries are coming. But the important thing about this release is that this is the first time, and I think I can bet anywhere, that cassava varieties were released based on product profile classes. So we released one variety for fresh root, a product profile, the other product profiles for Gari and Fufu, 2 varieties, and the other 2 for industrial. And this is very good now because it gives us we understand that this is important for farmers. They understand what they want. They understand what they are being given, and they can make a specific request for purchase of seeds of any of these varieties, knowing what they are going to do with them. Before, we used to breed varieties for everything, which doesn't happen in reality, but that was what we used to do. So this whole system change has helped us to do that. Now, when you release varieties, what happens with them? In the past, we release varieties, they stay in the breeder's field, or let's call it shelf, for a couple more years. In fact, some of them don't make it to the farmers because there's no incentive to move them to the market as a seed, especially knowing cassava as a vegetatively propagated crop. Seed companies avoid cassava or other root and tuber crops. So, but we've been able to demonstrate that with our partners. Basics is a project funded by the Bill and Melinda Gates. We've been able to see that those 5 varieties we released last year are now being marketed by spin-off companies from this project. Umudike Seeds is the one in Nigeria at the national program, and ITA owns a spin-off company. And we have the same in Tanzania. And we also have a project called Muhogo Bora in Tanzania, which is making emphasis on raising female seed entrepreneurs. So we are working with these partners to see that the new varieties we release based on product profiles are going to be marketed, and they will get to the farmers faster than previously done. One of the things we've done also is capacity building. So for capacity building, this is a large number, but we are excited because this is Africa's future, raising graduate students that are studying breeding in different universities, whether in Cornell University in US or in Africa. But the fear when we wanted to start this was, will the students return back? But we have these 3 cases as our excellent examples. Mercy is, let me say, the operations manager for the seed company ITA Go Seed. Ismail Kayondo is a top-level postdoctoral scientist at ITA supporting Ismail Rabi. And Lydia is a top research scientist at NRCRI, studied in different countries under NextGen and returned back, and they are contributing. And there are many of them that I can mention. These were the 3 best cases. And I can tell you that we have up to 80 to 85 retention in the national programs of these students. Now, we have been focusing on the big countries that produce cassava, Tanzania, Nigeria, and Uganda in Africa. But we had the spirit of none should be left behind. That's what we call the Community of Practice Partnership, COPP. So, and we use the spoke, the hub approach. The main countries I mentioned are the spoke, while these were the hubs. And what would they do? We shared learnings and resources with them, peer-to-peer visits, safe germplasm exchange. We even exchange our breeding materials with them and support them in field management, trial management, and data, and even some basic field resources, field tools that they need for their work. And we train them in the digital digital ecosystem, Cassava base, that they are now beginning to use. We've also done this quality control using molecular markers for their breeding populations and train them on how to use those data, because they need to come up to speed to be able to serve their countries. Some other capacity building exercises we've done are how to use the Cassava base to run the entire whether trial, design, evaluation, and all the things I mentioned before that we use for database. So you can see the number of people we've trained in recent times, and training is ongoing. Even during the COVID, we had to switch to virtual training. And one big thing we've done is to build capacity at the national programs, high throughput phenotyping, and evaluation of root quality traits. So whether you're a national program or CG Center, we are giving everybody the same push based on your strength, and we've seen progress. One thing we noticed in phase 2 is that we needed to increase our accuracy. So we had to raise what we call quality champions. So each of the breeding teams had quality champions, and these people's job was to implement a quality management system. So we plan, like is known in companies, we plan, we do, we check what we've done, and we act to correct any wrong step that we've taken. And this has helped us to ensure that everyone is aware of the best practices for quality management, and we've developed and implemented SOPs. Each organization will develop their own SOPs and will be validated in a community. And all the other things we've done, training everyone in how to use that. So I will end this talk with the next couple of slides, talking about why did NextGen succeed? I mean, based on the much we've been able to do. I must say that we've been a cohesive group, and that was important for us because we started small, and Jim mentioned Kathy Khan and Christina Owens, and even Jim, when he came, there was a lot of team building exercise that happened before we set out, and that brought about a cohesiveness that has remained till date. And we also respected partners. We treated NAS as co-equals. So everybody came on, and even the bigger programs were the ones pushing for the common good. We grew together with excellence in breeding. I mean, NextGen started before excellence in breeding, but you could see that every one of the modules of EIB was, NextGen was already doing some of those activities, and we've been able to partner and support excellence in breeding in the work they've been doing. We couldn't have done this work without our very great external advisors. Some of them are in this call, and they were the first people to tell us about quality control, quality management system. And when we looked in, we saw how much of an issue we had. We were having, mislabeling and all those things, but we had to, act on their advice. And they prodded us more towards collaboration. We're collaborating with multinational seed companies like Dow AgroSciences that has become Cassava, and now we're also partnering with the Bayer Group in ITA. They also helped us to always think about continuous improvement. The whole thing should be, NextGen Phase 2 was about continuous improvement, and it came from these external advisors. So we are very grateful to them. We also, some of the pillars on which NextGen rested was that we discovered that, specific quality control problems were there in our teams. and we had to execute a systemic action, implementing genotyping to do quality control of our parents and some of our selected offsprings as we go on. And it shows us how many mislabelings we are having, both in the lab and in the field. And that raised awareness that we have corrected now, and we have seen the progress that we've made at that. And that was what led us to forming quality champions, Q-champs, and they are like the guides. They are responsible to ensure that everybody was doing the right thing, and that everybody owned the process of improving quality. We adopted a demand-led breeding at the time of the start of phase 2. And that was really a helpful thing for us, because that was the first time we are doing that in I guess in most public breeding programs, this was the first time. But for cassava, it was the first time also. And we know that it's a foundation for a strong future, implementing innovation in that manner, in a participatory manner, having gender as a pillar of that. And the other thing is that every one of the members of NextGen, without exception, I can tell you, are open-minded and very collaborative. Very collaborative. When it came to open access database, everyone embraced it. When others in other crop programs, at least I saw some, were very hesitant. And we became the pioneers in that aspect. Our bottom-up approach has ensured that individual leaders were also empowered and were seen to be responsible. Again, it doesn't matter whether you're in the national program in a rural community or you're in a CG center. And so what take-home lessons do we come away with today? That with the right tools, even challenging crops like cassava will respond effectively to selection. With the right tools and the right people, I must say. In cassava, we have made great strides in modernizing breeding and in technologies, and even attitude and focus. People have a different focus now that accuracy is important. People have a different attitude that we need to continue in continuous improvement attitude or mentality. As a model, NextGen was not built in a day. We went through a process of team building that brought us to where we are today, and it has led to great progress for the crop, and is an example for any crop to follow, any crop community to follow. We exist, and we will continue to innovate because we know that there are smallholder farmers who are hopeful for new opportunities, new income opportunities from the better varieties that we will be releasing. And we think that this project, NextGen, represents a flagship model for RTB crops, that's the root tubers and bananas, that the 1CG is taking over, in the next few months, maybe 3 months from now, we will have the 1CG fully implemented across the CG centers, and they will want to work with national partners. So we've been able to show that NextGen is the right model for a CG national program, and even advanced research institutes like Cornell University having a network, a breeding network, and that leads towards building a capacity at the local level, capacity for breeding at the local level. That is what NextGen has been able to exemplify. And we're blueprinting outsourcing high-end advanced research activities to organizations that, things that we cannot do, like bioinformatics and all the other things that we could not do. We have learned and we have already worked that out. Is a cost-effective way for collaboration, and sustainability is there. We help design and link to seed system projects that I mentioned earlier on, which is important for the market end of the project. So I'll end this talk by saying that modernized cassava breeding is essential to Africa's food security future, and NextGen represents that a lot. So thank you for listening, and I will be glad to take any questions. But I must end with thanking the Bill and Melinda Gates Foundation and the FCDO of UK for funding this project. Like Jim said, without relenting, even when when there were issues of COVID and everything, we've been consistent over the years. So we are very grateful as a project, and my team and I are very appreciative of all that you've done for us. And actually, you did for African smallholder farmers. Thank you.
Chiedozie, thank you for an excellent presentation, and thank all the team that stands behind that. We'll move right into questions, and they're just starting to come in, but I'm going to pick up one from one of our deputy directors, who's also our acting director now. It's a two-part question. How does NextGen fit into the 1CG? And are there any transferable lessons with regard for IITA's leadership?
So maybe that question was asked before I made the last couple of slides. So how the NextGen relates with the 1CG is the 1CG, one of the things I remember the 1CG wants to do is to support the breeding programs, not just in the CG centers, but to make sure that at least 30% of their resources are channeled towards support for the national program. And I've been discussing with the 1CG leadership on the sides, and that has been that NextGen's support for the national programs was even more than 30%, and we've seen the result. Like, you need to go to a national program like Uganda to see how competitive they could be. So the question about how does NextGen fit into 1CG is that it has become a model that the 1CG can leverage on, especially for crops like RTB crops. I bet for other crops also. I'm not sure I got the second question.
Yeah, transferable lessons with IATAs, or for that matter, the 1CG's leadership.
Right. I think it started from the beginning, team building, respect, and openness. When you are open to partners and you treat them that way, there's a different kind of response and the openness that comes. So we demonstrated that with NextGen.
Thanks. Clearly, national partners are going to be key to the success of the 1CG. I know there's another question, but I'm going to jump in with one of my own. How do you think adoption of Cassava base has affected the uniformity of operations and protocols across the partners involved in NextGen?
Right. Just about the time we were starting, and we started and knew that from day one we needed a database, but we had partners in that must have been integrated breeding project managed by CIMIT back then, some years ago. Started what we call trait ontologies. So they got it to a point, and we had to pick it up and added a lot more traits to the trait ontology, defining the trait terms. What do you mean if I measure plant height? Okay, plant height is a simplistic one. If I'm saying my variety is resistant to root rot in Brazil, does it mean the same thing in DR Congo? So we had to define that, and the community agreed on that, and then we uploaded that. So it became a community tool. With that, we integrated that into the Cassava base. So when you have to score, you use those tools, you use the same field app, you use those tools to score, and you know that if I say is root rot resistance because it's not scoring high, then it means the same thing anywhere in the world. So we have that for all the traits that anybody could think of. And there are many traits because we know that different countries or different regions have different emphasis on the traits that are of importance to them, whether disease or food quality. So that has helped us. And with the curation that was coming from Boyce Thompson Institute of Cornell, that where our partners there led the development of this cassava base. So that helped us to bring everybody to the same page. And the other thing is that we agreed that once you have your data, you upload it there. Our genotype data, the SNP data are also uploaded there. So everybody was playing in that field of cassava base. So that is very good for uniformity. And we hope that we'll be able to continue on that light even after the end of this phase of the project.
Thank you. I hope so too. A question from Lawrence Kent. Can you speak more about the decision to move from long cultivar code names to brand names like Game Changer and Fine Face to facilitate their promotion and marketing of the newest varieties to farmers through seed entrepreneurs and their associations? And also, have the new brands been more memorable, and has that begun to catch on?
Right. Thank you, Lawrence. I'm smiling here because it was a big experience for us and a big change. So in the past, we retained the names that breeders gave. It's not even names; they're codes that breeders gave to varieties, and we try to, promote them on that basis. But you end up seeing farmers name the varieties their own local names. So you may have one variety being named. You can have one being named Okoyawo in one part of Nigeria, and you go to another part, 3 different names, 4 different names, because they could not cope with that number, or it's not their problem. So they'll give it a name that suits them. So we saw a learning from there. Why don't we develop new varieties and let the farmers give them names? So with the partnership with the seed project Basics in Nigeria, and we're now implementing that also in different places. With partnership, we met together, NextGen and Basics, and we identified these new varieties that we were ready to submit for variety release to the variety release committee, and even some very popular ones, like 5 of them we had before, and we called farmers, processors, including women farmers, including market women, who say, these varieties, they knew them. We said, let them give them names that they liked. And they selected names, they voted those names, and they gave those names according to how they give the names in the past. But they gave the name that everybody will agree on and work with. And that became the brand name. So we now switched from code names to brand names, which these new seed companies that were also formed, focusing mostly on vegetatively propagated crops, ITA Gold Seed, there's Kilimo Gano in Tanzania, and Umudike Seed in Nigeria. So we have those companies now marketing these new varieties with the new names and also based on product profile. So this is a complete suite and a complete switch from the past that we are seeing now, and we have seen progress since then. Thank you.
Thank you. It's slow on the question asking side, but I have another one. This hasn't always been a linear process. There have been learning examples. Can you tell a little bit about why IITA decided to back off a 1-year cycle in breeding to a 2-year cycle, and what the future might hold on that as well?
Yes, a couple of things, but the first one was, it was a lot to handle. We're also moving from few numbers to a lot of numbers. So we needed a whole lot of mindset switch from what we used to do. And, dealing with all of that with, rapid selection was quite a thing. That was on one side. Then there's also the biological side of cassava. So when you look at cassava, it doesn't flower until it branches. And we saw that we were now selecting those that are early flowering because those are the ones we could use to achieve the rapid cycle. But at the end, most farmers don't want things that are very low branching because you don't have, even if you move them, advance them as the candidate varieties, you don't have seed to multiply, or you don't have seed to market for the companies to market. So we had to change that, all of that, because we think, like I said, we don't want to be running so fast to nowhere. It has to make sense when you are running fast. So the direction was to give the best varieties that met farmers' needs. Farmers were not going to take very dwarfish plants, and so no need to move on with that. So we had to step back. And since we stepped back, we've seen the progress. We've moved from first 1 year cycle at ITA. We actually said the national program should stay at 2 years to reduce the risk. But after ITA tested it and we saw the issues, ITA also had to backtrack to move at the same pace with the otherwise we would have had more than 6 cycles for ITA by now if we were running at that speed. But again, we needed to make the speed meaningful. So it's very important.
Thank you. And one last question. Oh, was somebody jumping in? Okay, one last question. Would someone please comment on how the NextGen team is thinking about integrating engineered traits, transgenics, gene edits into the breeding pipeline?
Right. So I'll just make an attempt, but so what we've done in phase 1 was to understand, have a proof of concept. Number 2, phase 2 was to begin to even harmonize things, improve on the quality, and see how sustainable the whole effort is. And we've made this progress, and we are still making progress. There's some things I mentioned in the demand-led aspect that we need to fine-tune the tools, the citizen science tools that we are using. So those are learnings we are having now, hoping to implement in the near future. In bringing in new technology tools like GM and gene edit is something we are open about, and we've also had a lot of discussion with partners at the Donald Danforth Plant Science Center, how we could even support some of the work they do. We also are working with some of our partners in Germany on a cassava source sync project, on how to use those tools to improve, what do you call it, to expand the genetic base for some traits of interest that will lead to higher productivity. So I will also end with the other partner in Urbana-Champaign, Illinois, Steve Long, who is doing a lot on manipulating the photosynthetic efficiency of crops. So these are people we have started scoping discussions with, and we are fine-tuning how to make that partnership work in the future when the opportunity arises. For example, our team members in Boyce Thompson Institute who are responsible for cassava base are also talking with these people on how to develop a special line database that incorporates the kind of traits they use and the kind of tools that they use to develop new varieties. At the end, it will become only a trait because it's a trait breeding, it's a trait pipeline that they serve. So when they finished with the trait and those traits are down-regulated, it is just natural for us to now begin to use them for the traits that are very intractable for us to manage. We see gene editing as a tool. For example, there's post-harvest physiological deterioration. There's this increasing the photosynthetic efficiency of plants, of cassava plants that's already demonstrated. So those are tools. Those are trait pipelines that we are very interested in, and we want to introgress into our breeding program. There's even the double haploid that we also will be interested to work together with in the future. But we have this map we call HapMap, haplotype maps that we can use to make this very easy, coming soon. We've laid the foundation as NextGen, and we hope that going forward into the future, the next 2 years, next 3 years, 5 years, we'll be able to tell a different story of how we've been able to implement that.
Very good. Chidozie and team, I'd like to thank you for telling a very inspiring story. Even crops that start way behind in breeding can catch up quite rapidly and with modern techniques. And I think you're showing that very nicely. So thank you all. And if anybody wants to stay on for additional questions, if you're available, I'll leave it open. But thank you for attending, and excellent job in presenting a nice story.
Thank you, Jim. See you here. So while we're still at it, I want to thank everyone for attending, and thank you for the great support to the project. Thank you. And I'm sure there are a lot of other partners I didn't have opportunity to mention their names, like Wave Project, Justin, Peter, my friend in Abidjan, Cote d'Ivoire, and the team there doing a beautiful work with us in virus diseases, a virus epidemiology, understanding it in Africa. So thank you for everyone presence and your time. I'm still here if you have questions or you want us to talk. Thanks to all the thanks I'm receiving from the chat box too. I want to thank NextGen team members, Jean-Luc, thank you so much. Harley Tufan, Kanan, Ismail Rabi, Robert Kauki, Shofe, and many other partners I'm not seeing here, but thank you, Joseph Onyeka, and all the partners that joined us, the National Program people, the CG Center people, EIB, 1CG. Thank you for your time, the USAID.
Very good. Well, thank you. And with that, I'll wish you a good evening or a good rest of the day, wherever you happen to be. And very well done, Chidozie. Thank you.
Thank you.
Thank you,
Thank you,
Jim.
everyone. Thank you, everyone.
Thank you, Elizabeth.
Thank you, Jim.
Yeah,
Thanks
thank
to our
you, Jim.
advisors, Dave,
Thank you very much,
Yeah.
Legacy.
Steve.
Thank you, everyone. Dr. May, Carlos, all those good people. Jim, thank you. Well done.